Let's take a look at our next objective, which is to find the domain of a function. Domain is something that you're going to deal with the whole semester, so hopefully you'll have a really good understanding of what that is by the time we finish this course. The domain of a function is the set of x values for which the function is defined. We saw in the previous objective for the rational function there was a value that we input that made the output undefined, and so that value would have to be excluded from the domain. So we must exclude values from the domain of a function if that value, that is the input value, right, the domain is the x value, so we're thinking about what values of x or what input values makes the function undefined. And if there are no values that make it undefined, in other words it's defined for every single value of x, then the domain is all real numbers. But if there are values that make it undefined, then it's all real numbers minus those particular values of x. So what types of things make a function undefined? Well, when we divide by 0, as we just saw, but also when we take an even root, so like the square root, the fourth root, and so on, of a negative number. You might recall that, for instance, the square root of negative 4 is 2i. Right? There's not a real number that I can square to get negative 4. We have to express that as a complex number. So for the purposes of functions that we're talking about real values, then it would be undefined there. So we're thinking about, again, all of the real numbers minus the values of x that make the function undefined. So here again are some examples to review how to find the domain of functions. You may again want to pause the video at this point and try to do these on your own and then turn it back on and make sure that you got your answers correct, or you can continue with me. If I want to find the domain of these functions, f of x is equal to 2 plus 7x squared. Well, here I don't have to worry about any fractions, any radicals. I can plug any value of x into this, square it, and I get a result. So this function is defined for all real numbers. So we would say that the domain, you can either write it out as all reals, or you can write it, there's a symbol, this bold-faced R you can use to denote that, or you might remember that there's interval notation, negative infinity to infinity is a domain for all reals. Now what about f of x is equal to 1 over x squared minus 9? Well, here we have a fraction to deal with, so we have to exclude any values that make the denominator 0. So we would have to think about where is x squared minus 9 equal to 0, and pull out all of your solving equations skills. So you'd have to solve a quadratic. We can solve this by the square root property. X squared is equal to 9, where x is equal to plus or minus the square root of 9, which would be plus or minus 3. So we could write the domain here as all x except x is equal to negative 3 and 3. Now if you wanted to write that in interval notation, we have to take out the negative 3 and 3. So you can think about the whole number line with the whole at negative 3 and 3. So that would mean we would have all the values between negative infinity and negative 3, all the values between negative 3 and 3, and then all values to the right of 3. Now, the next problem, f of x is equal to the cube root of 4 minus x. Well, this particular function is defined for every value of x because the cube root of a number exists whether that number is positive or negative. So for an odd root, the domain is all reals. Now, the last function, g of x is equal to the square root of x squared minus 4x. I probably jumped here to a very, very difficult problem. You most likely recall things like the square root of x minus 4, where you just have a simple linear expression inside. Well, in pre-calculus, we're going to take it to the next level and deal with other types of expressions inside the radical. And so if I had the square root of x squared minus 4, for this function to be defined, I have to make sure that the x squared minus 4x is greater than or equal to 0. Now, to solve a quadratic inequality is a very long process. There's a way to do it by hand, there's a way to do it graphically, and I'll show you that in the last objective. To review this by hand, I would have to think about where is x squared minus 4x equal to 0, and I can factor that as x times x minus 4. Notice that is not the difference of two squares because of the x on that term with 4. So we get x is either 0 at 0 or at 4. And if you recall, now we're solving an inequality. And why am I doing this again? Because I need to make sure that that function is defined, and it's only defined where that inner expression or that radicand is greater than or equal to 0. So to solve this quadratic inequality, I would place my numbers 0 and 4 on the number line, and then I have to test regions or values in each of those regions. So like if I wanted to test a -1, test 2, and maybe test 5. So if I plug in -1 into that inequality, it's -1 squared is 1, minus 4 times -1 would be really plus 4. So that becomes 1 plus 4, which is 5, which is greater than or equal to 0. So that value makes that inequality true, so those numbers in that region would be included in our domain. If I plug in 2, for instance, 2 squared is 4, minus 4 times 2 would be minus 8. 4 minus 8 is -4, which is not greater than 0, so those would not be included. And then lastly, we plug in 5. 5 squared is 25, minus 4 times 5 is 20. 25 minus 20 is 5, which is greater than or equal to 0. So my domain of this particular function would include all the values below 0 and equal to 0, and then 4 or greater. So I can write my domain as the set of x such that x is less than or equal to 0 or greater than or equal to 4, but in interval notation, which I actually prefer, though I think your textbook uses this notation, I would have to write it as -infinity to 0 union 4 to infinity. Now, one last problem that I wanted to show you is one where we include both a fraction and a radical. So I've got to worry about two things in this problem. I have to worry about where the expression x minus 7 is greater than or equal to 0, and that's a simple linear inequality that I can solve by adding 7. So x greater than or equal to 0 makes that radical defined, but then I can't divide by 0, so I have to find out where is x minus 7 equal to 0, and I have to throw that number out. So this is saying that x has to be greater than or equal to 0, but it can't, x has to be greater than or equal to 7, but it can't be 7. So that means that our domain is simply going to be the values of x that are larger than 7. I have to throw out the endpoint of 7 because it causes that to be the square root of 0, which would make 0 in the denominator. So I could write that then as 7 to infinity.